Okay, now we place an electric dipole in an uniform electric field. This is electric field E. We have already calculated that the force torque. You have remembered that torque. If we place an electric dipole in an electric field, the torque is P cross E. We have already learned that torque is P cross E. P is the dipole moment. So we get P E sine theta. That is the dipole. The angle of that dipole with the electric field is theta. That is plus q and there is minus q. We have already learned that. The calculation of torque. Now you want to calculate the work done. What work done? There is work done to move that dipole to an angle d theta. Now if we want to rotate that angle in that electric field to an angle d theta, then the work done will be what? Work done will be dw equals to tau d theta. Why? Tau is here tau stands as force, d theta is the displacement, this is the angular force, this is the angular displacement, so force into displacement is the work done, so we get the work done is tau d theta. So if we want to get the total work done W, we have to integrate that. So tau d theta from suppose angle theta 1 to theta 2. Angle theta 1 to theta 2. Now we know, we have already learned that tau equals to P sine theta, so that will be Pe integration sine theta d theta from theta 1 to theta 2. Sine theta d theta from theta 1 to theta 2. So integration of sine theta d theta will be cos theta. So we get Pe cos theta. If we put the upper limit first, cos theta 1 minus cos theta 2. Actually that work which is done on that dipole to move the angle d theta now from theta 2 to theta 1, theta 1 to theta 2, that work done is stored on that dipole as a energy, potential energy. That amount of work which is done to move that dipole from theta 2 to theta 1, that work done is stored as a potential energy into that dipole. Okay, now understood. So that is the expression of work done. That's the expression of work done to rotate the dipole in an electric field from angle theta 2 to angle theta 1. Now if we take that theta 2, now if we take that theta 1 is 0, theta 1 is 0, that is initially the angle between the dipole and the electric field is 0, and the theta 2 is theta, that is any angle theta. So we get W equals to, from that expression we get W equals theta 2 is theta and theta 1 is 0, cos 0 means 1, so we get Pe cos theta minus 1, cos theta minus 1. 1 minute, I make some mistake, I think. Integration of sine theta d theta, it gives minus cos theta, isn't it? It gives minus cos theta, so that will be actually minus cos theta 2 plus cos theta 1, isn't it? Integration of sine theta d theta, integration of that sine theta and d theta, we get minus cos theta. So that become minus cos theta 2 and that become plus cos theta 1. So we get here 1 minus cos theta. That is theta 2 is theta and cos theta 1, that is cos 0 is 1. So we get 1 minus cos theta 2. This is the work done to move a dipole from angle 0 to any angle theta. Now if we take that initially theta 1 is any angle theta, we take theta 1 as any angle theta and we move that theta 2 to 90 degree, that is perpendicular. Now we place, suppose that dipole first of all initially making an angle theta with the electric field and we rotate that dipole to 90 degree. Then we get W equals to theta 1 is theta, that is cos theta, and cos theta 2 is 90, so cos 90 is 0. So we get Pe cos theta 1, we get Pe cos theta, that is P dot E. This is another expression of work done, P dot E. Whatever you get, that is a general expression, Pe minus cos theta, Pe minus cos theta 2 plus cos theta 1, we get that. Actually there is a general expression. Now you can put theta 1 equal to 0 or theta 1 equals to 90, theta 2 equals to theta or theta 2 equals to 0 or 90, anything else. That is if we rotate the dipole from an initial angle to a final angle, this is a general expression of the work done, and that work done is stored as a potential energy into that dipole. This is actually matter. So we complete that chapter, go through the video first of all, and then read the chapter properly and do the sum. If you get any problem to understand any point on that chapter, and facing any problem to solve your numericals, just ask me. Just send the numericals in WhatsApp. I just make a group and send that video on that group. So if you may face any problem, just let me know on that group. Okay.